Hi everyone. Welcome to my idea of an algebra course that would lead you all the way to GCSE. I'm thinking algebra is one of people's biggest bugbears, and sometimes they don't see the point in it, but it's one of the best things you can do. And you'll get better at it, and you'll see exactly why. If you can do something with numbers, the natural next step would be to do it with awkward numbers. And then the next natural step would be to do it with any number, and then that's pretty much algebra. Before we start, there is some knowledge that we'll need to have beforehand, which is not algebra necessarily, but it's actually really important. Some of the really, really important stuff, which are fractions, I've included in some of the questions, so that should help us. But there really are some basic ones. So we'll go through them real quick. That's calculator skills. You've got to be able to use a calculator, turn it on, square, square root, plus, subtract, times. That's a really important one for questions that require it. For example, there are some methods that will ask you to solve equations, and you can use a calculator to do that, to verify, to double check. Remember, always take the hardest road. If there's a method that you have to do, don't seek the easiest, quickest, cheat, con, whatever. This is going to rob you of your ability and your own thinking process, right? You want to be
Uh-huh.
able to think critically, and you want to not rely on things as much as possible. You want to be an independent thinker.
Uh-huh.
So make it hard for yourself and choose the hard road. And that's what this is all about. A problem-based curriculum is what we have here. All right, so next is prime numbers. You're going to have to know your prime numbers. That's 2 and 3, 5, 7, 11, 13, etc. And to be honest, you don't need to go too far before that's useful, because there are not really many numbers with a factor 31. I would say the most common probably stop at 13. And your times tables, you ought to memorize it. Now, the thing about times tables, you have to understand that if every single time you wanted to do a calculation, like 6 times 10, if you didn't know the answer to that like pretty instantly and you have to calculate it on a calculator, you actually lose your way on the path to your strategy, because you're always being stopped. So memory is one of the most important parts of learning, and it's often overlooked for problem solving, but you need a base of it. So commit them to memory, and you're going to start seeing an increase in your strategy. Operations, you have to understand the operations at the basic level there. We have plus, take away, divide, times, square root, and square, and the opposites. So plus is the opposite of take away, divide is the opposite of times, and square root is the opposite of square. So if you do that one after the other, it undoes it. For example, I've got the number 3, and let's say I square it, but then if I square root that, then that cancels out to just be 3, because square root and a square, they sort of get rid of each other. Same as if I had 3 and it's like a plus 3, and I take away 3, it cancels out to be 0. It's like the opposite. Okay, so opposites are important. You probably know this. Square numbers, these are if you multiply numbers by themselves. It's always easy to find square numbers in the exam. You just do 1 times 1, there's your first square number. 2 times 2, there's your second square number. 3 times 3. And if you therefore know your times table, you can just rattle these square numbers off in the exam. So here are the square numbers. And you probably want to actually go up to maybe 15 squared, which is 225. And that would probably be all that you'd need, apart from the really clear and obvious ones, like maybe 10,000, which are like 100 squared. So it's like really obvious. Cubes are the same number multiplied by itself 3 times. So 1 times 1 times 1 is 1. In the same way that we did the square numbers, we can rattle them off in the exam if you're stuck and you can't remember them, right? So we'll stop at 4 here. And then you'll see that there's only one more really, and they don't go beyond 125, I don't think. So once you feel you're ready, once you've done that, sorry, and you feel that you understand that, you're ready for this course. Um, it's a problem-based course, so I've released it ahead of time, and what you'll need to do is go through them as best you can on your own and research them. There are some rules though, okay? So we'll go through them now. Because it's a problem-based curriculum, you start by understanding the problem before jumping to the answers. This is so common to jump to the answers too early, and it creates dependency, right? And we don't want dependency, okay? That's a bad thing. You want independence. Work together with others and listen, don't compete. So working together is a nice thing. There's no reason why you can't. What you don't want to be doing is getting the answers from somebody else who's just telling you, right? So you might want to work with someone who also wants to get better at algebra, and you're both starting at the same place, always explain your thinking, and the answer doesn't really mean anything. Like some folk are obsessed about getting to the answer, and it really doesn't matter. The most important thing is the method, and so explain it and be as crystal clear as you can. You've got to imagine that the person you're talking to doesn't know diddly about you, and you have to convince them that you know without just guessing. Okay, so it's about not guessing. And don't panic if you feel stuck. That struggle is part of the learning. I once took 2 weeks on a problem myself, and it felt like I'm really not making much progress here. But after 2 weeks, all the research that I'd done to get that problem sorted, that was my journey, my story, and at the end of it, I was really strong at maths. I learned things that accelerated my learning in other areas. So you're in your own race with yourself, but don't panic if you feel stuck. Stick with it, and don't be surprised if the problem takes you a week or two. If you're a professional mathematician, it could take you years. I'll give you one example where Terence Tao took 2 years to solve a problem in a group effort of four. But another example where Andrew Wiles took 30 years to solve Fermat's last theorem. So some problems really do linger. Hopefully, some of these will not take you that long, but it's all relative. Break problems into smaller parts if you need to. Okay, look things up only after you've thought it through fully. Okay, so that's another part of not being dependent. Reflect on everything you do as you go along. It might be a good idea to have a diary, which turns into a revision guide that's personalized to you. A very powerful thing when you've made it yourself. Focus on the process. I've kind of already said that in a way, but yeah. Anyway, taking responsibility on your follow-up learning. Okay, so what do you need to address afterwards? So that's a part of reflecting and making a log as you go, and never give up, never back down. So these are some general rules that I was just thinking would be really useful. I think it's time to sort of dive into it. So our algebra masterer. um, yeah, I'm right with this. Our algebra mastery worksheet, 139 practice questions from 0 to 5 plus-ish. Why is it plus? Well, because to be fair, you're not going to get a grade 5 if you just, aim for a 5. I think this is a moon. Okay, I've just drawn the moon. And what they say is that if you aim for the moon, what is this in our terms here? It might be a 6, right? If you aim for a 6, then if you miss, then at least you'll be amongst the stars. You heard of that one? That's a pretty nice metaphor for it, because really you've got to aim higher so that when the stress comes in the exam, it's a bit of slack there. Okay. The way that people have voted for this to happen is that we're going to be doing it like short videos. Now, the way I'm going to do this is to hopefully break down and use methods that are as much as possible first principles. If you only know a trick, for example, here you might divide the top and the bottom by 6. Okay, great. That's actually a bit more of a trick. It doesn't necessarily show an understanding of why. So I'm hopefully going to use methods that will show you more or less why things work, and more importantly, keep structure. Okay, so that's actually so important. I might even make a T-shirt on that, because like keeping structure has been the discipline that was necessary to keep you in focus on a question and not get lost. We'll come back to structure, I'm sure, plenty of times. Okay, my idea was I would zoom right the hay in. It's actually really high def, which is nice. And that means I'm going to get a lot more bang for my buck on the page, right? So I'm going to get a lot more space to be writing. So let's get going.